Alright guys, we're moving into 3.5, slopes of lines. So if you've done slopes before in the past, you probably get an idea where these warm-up problems are coming from. But go ahead and take a moment and simplify each one of these fractions and then check your answers when you're done. Okay, so here we go. First one, again, obviously in this case, if you think m, normally that's what represents slope. When we're dealing with slope-intercept form. We will review some of that as we move forward with slope. But anyway, we're just simplifying these. So for the first one, it's pretty simple. You just go 7 minus 5 on top. 7 minus 5, that's going to be 2. 8 minus 3 is 5. So just good old 2/5, nothing really crazy on that. Okay, number 2, we have a negative 3, and then we're going minus 6. So you're already at negative 3. From there, you're taking 6 away, so you're getting deeper. You have a 3-foot hole, and you dig 6 feet down from that. You'll now have a 9-foot hole, so negative 9. Next, you gotta, again, hopefully we are good at this, minus a negative. We're subtracting a negative number, which means we're actually adding that number. So 5 minus negative 1 is going to be positive 6. Now again, just remember on this, we do need to simplify that fraction. We can simplify by dividing the top and bottom by a common divisor. So in this case, 6 and 9 both go into 3. So divide the top and bottom by 3. And you're going to get negative 3 over positive 2. So number 2 should be negative 3/2. Next up, number 3, we have another minus a negative 4, so we're going to be adding 4 plus 4, which is 8, divided by 2 minus 2, which is 0. Now again, in this case, our answer is going to be undefined. I'll give you a quick explanation of why that's undefined. I'm going to do that off to the side up here. And it's easy to explain this with just a couple of quick examples, but you cannot divide by 0. But a lot of people just say that, and you don't really understand why. So again, we'll do a couple quick examples, like 8 divided by 2, and then I'll go, let's go, 2 divided by, let's do 2 divided by 4, and then we'll do 6 divided by 0. Okay, so first up, 8 divided by 2. Now, again, hopefully you know the answer is 4, but the question is, why is it 4? Well, what you're doing is you're saying 2 times what number and will give you 8. So in this case, 2 times 4 equals 8. So that's why we get 4 for our answer. 2 times 4 is 8. Next up, 2 divided by 4. Now if you go 2 divided by 4, you get 1/2 or 0.5. And again, the reason why is 4 times what number equals 2? Well, that would be 0.5 or 1/2. And that's going to equal 2. So when you get down to this one, the question is 0 times what number equals 6? Well, 0 times any number is 0, so it's impossible to multiply 0 by something and get 6. So basically it's a big old question mark. There's nothing that will work for that, which means your answer is going to be undefined. It has no answer. So that's why you can't divide by 0. Okay, so when you get anything divided by 0, it's undefined. Now, just to kind of bring this all back around, if I went 0 divided by 6, you would ask yourself the same question. 6 times what equals 0? Well, 6 times 0 equals 0, and that's why when you have 0 divided by a number, it's always 0. But if 0 is in the denominator, it's undefined. Okay, so where it's located in the fraction obviously matters. Alright, so anyway, that's number 3. We had undefined for that. And that leads us into number 4. Negative 3 plus 3 is 0. 1 minus 6 is negative 5. So normally if you had a positive divided by a negative, it would be a negative. But 0 kind of rules all that out. 0 divided by negative 5 is 0. Okay, so that's our warm-up. Again, obviously it has a connection here with slope, so we'll be doing similar things as we move through this section. Okay. So again, the objective of today, obviously you can see the title, slopes of lines, so we need to be able to find the slope of a line. But we're going to be talking in particular about slopes of parallel and perpendicular lines. And again, you'll see this written on the following pages, but again, parallel lines, we're going to be dealing with lines with the same slope. And when we're dealing with perpendicular lines, we're going to be dealing with opposite, reciprocal slopes. Or you can say slopes with a product of -1. Again, these are all things we're going to be talking about as we go through. You'll see examples of that. But if you, and I'm going to say this later too, so if you want to save the notes on this for later, an opposite reciprocal slope, if I had a slope of A over B, it doesn't matter what the number is, the perpendicular slope, this is a symbol for perpendicular, it's like an upside down T. The perpendicular slope would be the opposite, which means this case negative if I had a positive for my original, and the reciprocal means you flip the fraction. So that's what an opposite reciprocal means. Now if you want to find the product, you would go A over B times negative B over A, and you would multiply those together, cancel out your B's and your A's, and basically you'd have 1 times -1. Well, 1 times -1 is -1, so that's where the second concept comes from. Slopes are going to have a product of -1 if you're dealing with perpendicular lines. Okay, and that's a quick summary of this entire unit, actually. So this is a good, like I said, good summary. Okay. So anyway, just got to remember what a slope is if you don't. Again, the slope of a line or coordinate plane is a number that describes the steepness of the line. The bigger the slope, the steeper the line. The smaller the slope, the less steep the line. So any 2 points on a line can be used to determine that slope, and we use a concept called slope equals rise over run. Again, I keep getting ahead of myself, but that's fine. It's fine to repeat myself in that case. Alright, so again, definitions here. These are all definitions, they're not theorems or postulates. The rise, when we do rise over run, is the difference in the y values. Think up and down y values. The run is the difference in the x values, so that's left and right. The slope is going to be rise over run. Again, remember, it's rise on top of run. Or we calculate that rise by subtracting the 2 y values and subtracting the 2 x values. This is a quick example of rise over run. You just count from one point to another, and you can count the rise and the run, or you can subtract your y values to get the rise. So if this point was at 5, 7, and this point here was at 1, 1, you can count the rise and run, or you can say the rise, in this case, is 7 minus 1, and the run, in this case, is 5 minus 1. So that'd be 6 over 4, which is what we have, and simplifies to 3 over 2. Okay, that's again, quick little summary of how to find slope of a line. Alright, using that, let's go ahead and find use that slope formula to determine the slope of each line of in this equation. Then again, we're just going to do rise over run. So let me quickly label these points for each one of, the points. So A, it looks like it's at -2, 4, 5, 6, 7, so -2, 7. Looks like B here is at 3, 7. Looks like C is at 4, 2, and D is at -2, 1. So what we're trying to do in this case is find AB. I'm going to do at least one other one while we're at it. So we'll start with AB. So AB, we're going to do rise over run. Again, you can do it a couple different ways. You can subtract the x's and the y's, and do it that way, or in this case, you have the line in front of you, you can just count, and that's what I'm going to do here. So when I'm on line AB, it looks like I'm not rising at all. I'm going from 7 to 7, so the rise is 0, which can happen. The run, I'm going from -2 to 3, so I'm going right. You can just count 1, 2, 3, 4, 5. I'm going right 5. So that's just going to be 0. Okay, now that's one of your special lines. This is obviously a horizontal line. You can see that. The other one, if you want to see that vertical line, I'll do that one while I'm at it. Just change my colors here. So I was going to do AD. I meant for that to be black, but whatever. It even says black on my screen, but it's not doing it. Is that black? Hey, that's black. Okay. So AD here, I'm going to go, looks like I'm going down. If you see my rise, you can count 1, 2, 3, 4, 5, 6. So it's -6. But you're not going left or right, so this is going to be 0. Remember, when you divide by 0, that's undefined. And again, is what you should be able to see here, and I'm getting ahead of myself every single time here, but that's fine. This would be a vertical line. Alright, so obviously these are your two special lines. We'll do the AC one as well. I don't know if it's on the next slide or not. Yeah, it is. So we'll just do, I already did AD. Let's just do AC while we're at it. And I'll do it back here on this slide. So AC. AC, just a normal slope. Looks like it's going down though. Starting at A, let's go to C. So we're going to go down. I'll do a highlighter on this. So we, if I can find a highlighter. It's probably going to be a little thick, but that's fine. So I'm going to go down. So if you want to count how far down you went, let me try to get my colors here to match it. Okay, so if I'm going down, it looks like you're going down 1, 2, 3, 4, 5, 6. So -6. And I'm going to go right if I'm going to C. It looks like I actually messed that up. Let me fix it. Actually, it looks like we're going down 5 if you count that. So if I go down 1, 2, 3, 4, 5. Again, I'm trying to just get down as far as C. So that's going to be down 5. Then I'm going to go right. 1, 2, 3, 4, 5, 6. So it's going to be right 6. So if I'm calculating this slope, looks like I'm going to go down 5, so -5, right 6, and you got your slope. Again, we did the special slopes, the horizontal and the vertical, but normally you're just going to get a normal rise over run, and that's what we got on this case. Okay? Alright, so again, just to remember I went over the horizontal and vertical here. Again, a fraction with 0 and the denominator is undefined. We can't divide by 0. Okay, so we kind of went over that, and obviously if 0 is in the numerator, it's going to be a slope of 0, which is horizontal, which I already went over with you guys. Okay, now, if we are given points, again, we're not going to be, you don't have to graph, and I want to make sure that you don't waste your time graphing, and that's what we're going to do here. We're going to solve without graphing. So we're going to use the slope formula to determine the slope of JK through those 2 points. So again, all you need to do in this case is we're going to label these points x1 and y1. These 2 points, x2, y2. And remember, when we do slope, if you don't remember what I mean by the formula is y2 minus y1 over x2 minus x1. Remember, however, that's nothing more than rise over run. It means the same thing. Okay, so to find the rise, I subtract the y values. So that means I'm going to go -1 minus 1. And then x2 minus x1 is 2 minus 3. -1 minus 1, have a 1 foot hole, I dig 1 foot down from there, I'm at a 2 foot hole now. 2 minus 3 is -1. And in this case, we have a negative divided by a negative, which is a positive 2 over 1. Now, because it's a slope, I am going to leave it as a fraction so you can see what is the rise, and you can see what is the run. Okay? Alright, so again, we've kind of talked about some of these already. We talked about the zero slope, the undefined slope. Again, these are your regular slopes here. You got negative slopes when you're reading. Think about it again as you're reading like a book. So you read from left to right. As you read from left to right, if your graph is going up, it's a positive slope. As you read from left to right, if it's going down, it's a negative slope. Okay, just make sure you read from left to right. I'll even put that up here. And then again, the zero slope, it's not, as you read from left to right, it's not going up or down, which means it has no slope. And then your special one, the undefined slope, that's your vertical line. Okay, we've kind of tried to do a couple of these examples specifically to help you understand those special lines. Now, and as a little side note too, if I was going to graph this line, because we have to do that every now and then, this is going to be always y equals a number. For example, like this could be, this is going up 2, this could be like y equals 2. Okay, if you want to graph a horizontal line, it's y equals a number. If I want to do a vertical line, conversely, I do x equals a number. In this case, again, if I was going 1, 2, this equation could be x equals 2. So that's kind of taking the concept one step farther by actually finding the equations of those lines. And those lines would have either a zero slope for the y equals 2 or vertical, which is undefined, slope for x equals 2. Alright, quick word problem. I'm going to draw a graph here to represent the situation and find the slope. So it looks like Justin is driving from home to his college dorm. So at 4 o'clock, so we're given 1 point. At 4 o'clock, he is 260 miles from home. At 7 o'clock, he is 455 miles from home. So we need to graph a line that represents his distance from home at a given time, and we're going to find and interpret the slope of that line. So at this point, again, we want to try to figure out what kind of graph do we want to have, or not what graph do we want to have, what kind of scale do we want to have, because it just depends on where you want to start the time. So from here, we're going to, again, set up an XY axis, and almost all the time when you deal with an actual word problem, which we are here, and again, this is not always, but it's normally going to be this way, you typically aren't dealing with negative values. Again, obviously there are times you can, but like if you think about this time, we're just going to pick a time to start with, and your distance though is never going to be negative. So you know, because distance is never negative, your y-axis should never be negative. So I'm just going to pick some values for my x-axis, and I'm going to start at, let's say, there's never a time 0, but you can start at like 12 o'clock. And we'll do 12 p.m. as our starting point, just because it looks like our first time we have listed as 4. So this would start at 12 p.m. So as you go through the times here, that's 1, that's 2, that's 3, and 4, and so on. At 4, this is 4 p.m. And if you go out till 7, 4, 5, 6, 7, that would be your 7 p.m. In the end, it doesn't matter what you call the scale as long as it fits on your graph. So the next thing, though, if you look, it looks like we're going from 260 miles to 455. So you want this to fit, so you got to think of a good scale. I want to go up by 100s. I'm going to call that 100, 200, 300. Again, I got to go up to 455, so I'm going to go to 500, 400, and 500. So that's going to give you a good scale so everything fits on your graph. So I'm going to label my first point at 4 and 260. So 4, 260. So there's your first point. Then I'm going to go 7, 455. So 7, 455. And then we'll draw a line between those 2 points. So we'll attempt. Alright, so we got our line, and we got our points. So it says again, graph the line. I graphed it. That represents the distance. And find and interpret the slope. So let's go ahead and find that slope now. Now the way I'll do it is I'm just going to do good old rise over run. I'm going to start with this point. I'm going to rise and then run. And I need to count how far up did it go. Now if you can't tell how far it went, then we can still calculate that by doing y2 minus y1. So to find my rise, you would go 455 minus 260. So if you're doing that, you can do it down here, 455 minus 260. So that's 5. Let's carry 1 over. So that's 15 minus 6 is 9. And so it's 95. Now we find our run. Again, you can't count that. It's easy though, but if you couldn't, you just go 7 minus 4, which is 3. So as we calculate all this out, we're going to find the slope. So the slope of this line is going to equal 95, save space to the right, and then over 3. That's your run. So we have 95. What does that 95 represent? So looks like that 95 in this case is going to be my y-axis, which these represent distances in miles. So it's going to be 95 miles. And 3 represents the hours that have passed. So you're going, the slope is telling you you're going 95 miles every 3 hours. So that is your slope, but again, you want to represent what it means in this case. And again, you can always just think of this, and I'll put that in there, you can always think of this fraction as the word per. So if you wanted to write it out, you could say 95 miles per 3 hours, and that would always be fine. You just have to make sure you got your units right. And again, the y values are on top, the x values are on bottom, so the y values, these were miles, and these were hours. So that's how we know what to put where. Okay, moving on. Okay, so now we have some theorems. We have our, in this case, and let me get my color right. Sorry, let me get my colors fixed here. Okay, so we have our parallel lines theorem. It's our first theorem, and it says, in this case, that if we have 2 non-vertical lines are parallel, if and only if, biconditional statement, so it works for both the conditional and its converse, if and only if they have the same slope. Again, we talked about that earlier, right? But because they said non-vertical lines, this is like a separate rule. If they're vertical, any 2 vertical lines are parallel because they have no slope, so you have to state that as its own statement. Then the perpendicular lines we talked about as well. 2 non-vertical lines are perpendicular if and only if their product, the product of their slopes, I mentioned that earlier as well, is -1. That's the same thing as when we say they are opposite reciprocals. If they are, remember from earlier, their products will equal -1. I did that whole a over b times negative b over a, and I said that was -1. It's always going to work that way, okay? And then next up, because the horizontal lines don't have a slope, they're undefined, we have to make a separate statement for that. So it says vertical and horizontal lines are also perpendicular. Because if you kind of picture that, a perpendicular line, we have a horizontal or vertical line, and a perpendicular line would be its horizontal line because they'd form a right angle. Okay, but again, their products of their slopes wouldn't be -1 because, well, one of them 0, and anything times 0 is 0. The other one's undefined, so we'd kind of mess that up. So we have to state that one separately. Alright, so I already went over this, so if you want to write that back down, you can. But I already did it earlier, so you wrote it, you're good to go. Also, again, 4 points do not always determine 2 lines. Just so you know on that, why. There's some quick hints. I give you 4 points. You can have 4 points, and they could all be the same line. So I can have that. So those wouldn't be parallel or perpendicular. Or I can have 3 points on a line, and one of them that's not. So again, just be careful on those, and those. Make sure you check all 4. you'll see that we'll have 4 points in some of these coming up, or in your homework. Next, we want to graph the lines. So make sure they're not collinear. We don't want to have lines on top of each other. So in that case, make sure we're checking. Okay. So moving on here. So example 3, we're going to graph each pair of lines. So we need to actually draw a graph of these. We're going to use our slopes to determine whether they are parallel, perpendicular, or neither. Now the whole point of the graphing part is, if it's neither, just so you know, whether they show up in the notes or not, neither would mean that maybe they're the same line. If they're the same line, they're not going to be parallel. Also, if they intersect and they don't form a right angle when they intersect, then that would be a neither option as well. So again, we want to make sure we check the slopes when we do these. So I'm going to start with that. I'm going to find the, go back up here. I'm going to start by finding the slope of each line. Just kind of go with that. So the slope of CD. Graphing these is easy, but if you graph it, you can be compelled to say they're perpendicular or parallel when maybe they're just slightly off from being parallel or just slightly off from being perpendicular. So looks can be deceiving. That's why I like to do the slopes first. So the slope of CD, I have C, which is -1, -3, D's at 1, 1. So I'm going to call this first point x1, y1. Order doesn't matter, just if you call one point x1, the other's y1. I'll go over here, x2, y2, and we're going to find the slope. So that's going to be y2 minus y1. So 1 minus -3 over x2 minus x1, so 1 minus -1. So that's going to equal 1 plus 3, which is 4, and 1 plus 1, which is 2. So that slope is 2. From there, I'm going to find the slope of EF. So E is -1, 1, and F is 0, 3. So let's do that slope. Again, it's going to be x1, y1, and x2, y2. So y2 minus y1 is 3 minus 1. X2 minus x1 is 0 minus -1. Now, even though I have a 0 here, minus a negative is still plus. So this is going to equal 2 on top, but minus a -1 is plus 1 on top. So we have parallel lines. So I already know they're parallel, and you can go ahead and label that right now. And I didn't want you to graph them, so we'll go ahead and do that. So we're going to have our y-axis and our x-axis. I need to go just to 3. Now, if your graph isn't, if you have graph paper, this is obviously going to look a lot better than mine. Just doing a quick sketch. So here we go. First point, I have -1, -3. So I got my first point, C. I have 1, 1 for D. And I'll just connect these points. Wow, that's really bad, so let me fix that. Do my best. Okay, there's CD. And then I will do 0, 3 for F. And I'll do -1, 1 for E. And connect those. And again, they should somewhat look parallel. That should match your work. If you find that they're parallel in the lines, they should kind of match that. And hopefully they do on this. Okay? Alright, looks like this is going to be our last one. We'll kind of just wrap these up and then be set. Alright, so we're going to do the same thing here. WX and YZ, we're going to find the slopes. So we'll do this quickly. Start with WX. Same question. So I got W, which is 3, 1, and X, which is 3, -2. So this one I won't write x1, y1, x2, y2. We just hopefully know. So the slope here, and I'll use M for the slope, just to kind of remind you, M means slope, instead of writing the word slope out. you can use m instead. So here I'm going to go -2 minus 1, and then your x values will be 3 minus 3. So that'll be -3 over 0. So this will be obviously undefined. Okay, so now we'll go on to yz. yz, we have, let me fix that, we have y, which is -2, 3, and we have z, which is 4, 3. So we're going to subtract these, doing slope, y2 minus y1. So when I look at my 3's, I have 3 minus 3, and 4 minus -2. So that'll be 0 on top, and 6 on bottom. So that is a slope of 0. So remember what this means. We have a vertical line, horizontal line, which means we have, in this case, perpendicular lines. So when we graph these, we should see some perpendicular lines. So let's graph these. So if you look at my points, I only have to go out to 4. So that's what I'll do. 1, 2, 3, 4. 1, 2, 3, 4. Same thing vertically and up and down. Okay. Alright, so I'm going to label my points here. I'll just do it all in black. So we have 3, 1 for wx. We have 3, 1 and 3, -2. So 3, 1 and 3, -2. So that's wx, and we should have a vertical line. And then I have -2, 3 for my other line, -2, 3. That's y. And z is at 4, 3. And that is a horizontal line. So again, the way I have these drawn, they're not intersecting yet. I just can extend the line though. It's no big deal. And we have a right angle. These are perpendicular. Okay, so again, that would be an example of perpendicular. You can see it, and you can do it algebraically as well, or you can do both. Alright, last one. Okay, let's do green here. So we have KL and MN, so let's start with KL. So KL, we have K, which is at -4, 4. And we have L, which is at -2, -3. So let's find the slope. So M equals y2 minus y1. So -3 minus 4. Subtract those y values. Alright, y, -3, 4. X values, subtract those to get the run. -2 minus -4. And again, remember when we do that, well, let's get to that in a second. -3 minus 4, that's going to be -7. -2 minus a -4 is plus 4. So -2 plus 4 is 2. So we have -7/2. Alright, move on to MN. See what we get. So here we have point M, which is 3, 1, and N, which is -5, -1. So if I'm finding that slope, I'm going to go y2 minus y1, so -1 minus 1, over -5 minus 3. So again, -1 minus 1 is -2. -5 minus 3 is -8. Now in this case we have two negatives, which give you a positive 2/8. Now here we have two slopes that are completely different. They really don't have much in common at all. So if that's the case, then what you can say is that this would be neither. They're not going to be parallel, and they're not going to be perpendicular. So it should just be two random lines, really. So when you graph it, you should have two random lines. They're not going to have any particular special relationship between each other. So I need to go out 5 in this case. So 1, 2, 3, 4, 5. 2, 3, 4. I have to go 5 to the left, that's it. So there we go. Okay, so I'm going to plot my points. I have -4, 4, and -2, -3. That's 4KL. So I'll draw those lines. I'll draw that line. And then 3, 1, and -5, -1. And this is one of these scenarios where you can draw it and it looks like they're perpendicular, but as you can see with your work here, it's not. So that's why you're not going to accidentally call that perpendicular, is because you graphed it first trying to cheat your way through it and made a random guess and got it wrong. So please be careful on those. That's why I do the slopes first. Hopefully that helps you see that, because again, these look perpendicular but they're not. Okay? Alright, so with that, we should have a real quick, easy lesson quiz if you know how to do these slopes. We have 1 through 3. That's all it is. And then we got our reflections. Make sure you do those every single time. Don't forget. Alright, go ahead and get started on those on your lesson quiz, and good luck.